Okay, to solve linear systems, what does that mean? It means in grade 10 we are going to have two lines, and those two lines will cross at some point, maybe. Okay, if they do cross, then there is a solution. Two lines will or may cross at a point. That point is called the point of intersection. And where they intersect is where they cross, and that is a point, xy. And that is the solution. The solution is the point where they cross. So in this case, if we look over here at this graph, let's call this option number 1 and option number 2. We have two lines. They both start at different points, and they cross at this point right here. So if we go ahead and look at this, let's check and see what this graph is all about. The total cost of holding a prom at a banquet hall. Here's two options, banquet 1 and banquet 2 hall. So we look at this, the x-axis has to do with the number of guests. The y-axis tells us the total cost. So if I look over here at 60 and I follow this up, that is the x of the point of intersection. And the y is halfway in between here. I may have to do some math to figure out exactly where that is. So if this goes up by 400, that means one of these lines is 200. So 2, 4, 6, 8, 10, 12. Right here, this is 1400. And right in between that is going to be 1300 or 1300. That y is money, and this is number of people or number of guests. So in this case, they're asking us what the point of intersection is. The point of intersection is 60, 1300. But that's a number. We want to know what the significance of that means. So we need to go back and examine our graph a little bit more. So at at 60 guests, 60 guests will cost $1,300 for both banquet halls. So at 60 guests, it doesn't matter which banquet hall you go to. But what's the significance of that point is if you look here, this first one, it's going to get more expensive after that point of intersection. But before that point, the other one was more expensive. I know it's more expensive because I look and see that it's higher on the y-axis. That's a bigger number, which means it costs more. So if I asked you about which banquet hall I would go to, I would say if less than 60 guests are coming, I should go with banquet hall number 1. But if there's more than 60 guests, I want to go with banquet hall number 2. Go with number 2. So the significance of the point of intersection is really which one is higher at that point, higher or lower. In this case, the dotted line is higher before the point of intersection. Excuse me, but then it's lower after the point of intersection. The point of intersection is just where those two lines cross. So what we can do is, there's actually 3 types of methods of solving linear systems. What we just did above was really looking at a graph, but sometimes I won't give you the graphs. You will need to graph them before finding the point of intersection. So let's look at graphing. The first thing I need to do is graph both lines. So we just did linear relations. I'm going to scoot this up here. We can look and say it says graph both lines. This one right here is y is equal to mx plus b. It's in that format. So that means I want to start at the y-intercept, which is -1, and then I want to do the slope, which is 2. remember our trick to put that over 1. So it means up to and over 1. So I'm going to go to my y-intercept. I'm going to go up to and to the right 1, up to the right 1. If you want to do little bumps, just sometimes it gets your graph to be a little bit messy. So I count 1, 2, up, 1 to the right. And once you have a couple points, take your ruler and connect them. Try and be careful, and hopefully your pencil is sharp, because if you don't draw your line well, it's hard to find the point of intersection. Now the other one is not in the slope intercept form. So there's two options. You can use intercepts, so I can let x equal 0. If I say x is equal to 0, and I can see this is not much rearranging and stuff to do. If x is equal to 0, then this is 0, and I can see that y is equal to -4. So when x is 0, y is -4. That gives me the point 0, -4. So I could find that. That's 0, -4. And if I let y equal to 0, then what's x equal to? Well, if I let y is equal to 0, it's not there, then x is equal to -4. So that's my other point. X is equal to -4. So if I put those together, it's -4, 0. So I go to -4 and 0, that's on the y-axis. That's the y-intercept. And that gives me 2 points. And I connect those 2 points. And if you want, you can do it in a different color. I'll do it in red just so that we can see the difference. This one's in red, okay, and the other one's in pencil. And I can see they cross about here. It looks like the point of intersection is -1, -3. So -1, -3. So let's put that, it says right here, point of intersection, -1, -3. The problem is I'm not quite sure if that's right. So how do I check? Well, I do a left side, right side check. So I go ahead and look at my equation, and I think if these two sides were equal, it means that point is on the line. So the left side is just y. Well, y is -3. Okay, so the left side is y. Y is equal to -3. I got that from the point of intersection. What is the right side of that equation? I look up here. The right side is 2x minus 1. So let's write that down. This one's a little bit more work because I need to do some substituting. I look up here. The x part of the point of intersection is -1. So I'm going to fill that in. And now I'm going to go ahead and do the math. 2 times -1 is -2 minus 1. And -2 minus 1 is -3. So what I see is the right side is equal to -3. The left side is equal to -3. So that means left side equals right side. Check. It means it's definitely on that line. Now that's just for the first equation. Let's check it out for the second equation. So I'm going to go up here and look. The right side is equal to -4. The left side is equal to y plus x. So left side is y plus x. I'm going to check by putting in the x and y of the point of intersection. So y is -3 plus -1. This is where putting our brackets is important because we don't want to see two signs side by side not separated by a bracket. So if I do this in my calculator, it's -3 plus -1, which makes it more negative, brings you to -4. Well, I've seen that -4 already up here on the right-hand side. The right-hand side is just equal to -4. So left side equals right side, check. So we know that it's definitely the point of intersection if it satisfies, which means it works out in the equations. Now with substitution and elimination, we don't have any graphs. So we're just checking with algebra. So let's take a look and see what substitution is all about. You can use either one to solve a question, but one method can be easier than another depending on how the equations are written. So the first step says, check to see if one equation is written in the form y is equal to yada 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 or x is equal to yada yada yada. So if I look here and say, oh yeah, that is true, y is equal to, and you see some variables and numbers. So substitute means to put one into the other. So y is equal to all of this. So I can write all of that instead of y. So I'm going to write down the 3x. I write down the negative or the minus, and instead of writing y, I write a big bracket, and I'm going to write all this stuff. Negative x minus 6, and close the bracket. So what I'm doing is I'm substituting in for y what it's equal to with the x, the negative 6. So that's where that comes from. Y is equal to all of that stuff. But I have to continue and finish. So that negative is that 3x is that, but I'm not done. I have plus 10 equals 0. I'm still solving for the point of intersection. So it means I need to solve for an x and then solve for y. So I have a bunch of math here to do. I have to be careful. 3x. Now here we're doing distributing, if you want to think of it, or expanding. Negative times a negative is positive. So I have positive x because it's negative 1 times negative x is positive x. Negative times negative is a positive. This is like a 1 in front. So negative 1 times negative 6 is positive 6. I haven't done anything with 10, but you have to write it down. Now I'm going to look for like terms. So right here, any terms with an x are like terms as long as the exponents are the same. The exponents are the same. And if you've forgotten, if there's an x, it means there is a 1 in front. So if you need to put that 1 in there, go ahead and do it. So 3x plus 1x means that there's 4 x's. And those are the like terms there. Now these are just numbers. There's no letters, so they're like terms. So what I have is 6 plus 10 is 16. Make sure, though, it's a positive 16. You can't just put a 16 there. You need to have a sign in between them. Now these aren't like terms. I can't do anything with them. But don't forget, you want to solve for x. So that means I need to isolate it. I need to get it by itself. So I need to get rid of this term. To get rid of something that's adding, I subtract. And whatever I do on one side, I must do on the other. I chose it to get rid of it, so that's 0. And I have 4x equals negative 16, because 0 minus 16 is negative 16. Now, I don't want to get rid of this whole term. I only want to get rid of the 4 in front. So I divide by 4 because the 4 is multiplying. And I do that on both sides. I need to do this to keep it balanced. So 4 divided by 4 is 1, not 0. And negative 16 divided by 4, that's going to end up being a negative value. And 16 divided by 4 is 4. So that's only part of my point. That's the x part of the point. And I'm running out of space here. So you'll have to have smaller writing than me. I'm going to go ahead and continue here. And then I'll put in my point of intersection. So what I'm going to do is I need to find what y is. Well, let's go ahead and look back in the beginning. Well, I know what y is equal to. It's y is equal to all of this. So if I knew what x was, I could find out what y was. But I do, because I just found out x is equal to negative 4. So I'm going to write y is equal to negative x minus 6. Well, but I know that x is equal to negative 4. Now I know there's a negative in front of that, so you have to put that in, and that's why we use brackets, because x is equal to negative 4. And then I go minus 6. Negative times a negative, positive, minus 6. Minus 6 is there. 4 minus 6, do this on your calculator if you have to, it's negative 2. So out of all of that, what I found out is x is negative 4, y is negative 2. That is my point of intersection. So what I've done is I've used those two equations together to solve for x and y. So that should, if it is the point of intersection, it should satisfy both of these equations. So I'm going to check both of them. Essentially, I've kind of already checked this first one though, because I've used it. So I'm going to do this one first. So what I'm going to do is take 3x minus y plus 10. That is the left side of that equation. Okay, that's the left side. The right side, it should come out to be 0. So let's see if that works. 3, x is negative 4. Write down the negative in front of the y, but the y is also a negative value. There's a lot of negatives in this equation. So 3, x is negative 4, I have a negative, y is negative 2, and then I have the 10 from the equation. Make sure you're using brackets. 3 times negative 4, it's negative 12, because then this is a positive and a negative, ends up being a negative. Here I have negative 1 times negative 2, it's going to be positive 2, and then plus 10. And so I can see right here that 2 plus 10, if I added those up first, I get 12. Well, negative 12 plus 12 is 0. So left side equals right side, check. So it works for that equation, and let's double check. Left side is just y. I look here, y is supposed to be equal to negative 2. If I look at the right side is negative x minus 6. Negative from the equation. X is negative 4 minus 6. Negative times a negative is positive 4 minus 6. That's negative 2. And those are right as well. So that is a left side, right side check. You're checking to see that the left side and the right side of the equation are correct. Some people like that one better, but some people like elimination. Elimination means that you'll be actually adding or subtracting the whole equations to eliminate one variable. So sometimes you have to multiply your equations, but I can see from right here, it says decide which variable you can eliminate. I can look here and see, look, this whole term, this is a 4x, and if you want, I can put a little reminder of a positive in front of it, and this is negative 4x. So these terms are exactly the same except for the sign, which means if I add them, I'm going to get 0. So what I've done in class, I call this one A and call this one B. What I'm going to do is A plus B. So 4x plus negative 4 ends up giving me 0. Here, I could write it down, negative 5y plus 3y. Now everything on this side of the equation I'm still adding. So I have 7 plus negative 5. So you have to remember still that you're adding. I know that there's a negative here, but that comes from here, not because I'm subtracting it. So now I have some simplifying to do. These are like terms, so negative 5y plus 3y. Here we go with integers. This is a negative value, it's bigger. So it's going to end up being a negative value, and it's bigger by 2. But don't forget the y, because this is negative 5y. On this side, I could get rid of this bracket and just say it's really 7 minus 5, because this positive times a negative is going to be a negative. I'm going to write this down again. 7 minus 5 is 2. Now I need to get rid of my coefficient. That's the number out in front.